For this section, we're going to take a look at the comparison of two samples. We're going to do that through a hypothesis test, similar to what we did last time, and then we're going to also do it through confidence intervals. And so, specifically, we're going to be comparing the proportions of two samples and the means of two samples. And here are some example questions that we'll be asking that fit this model that we'll be using, or the models we'll be using. For example, here are two samples or two groups. Are men more likely than women to drink coffee black? Right? Our two samples would come from men and women, Democrats versus Republicans, right? And so you have these two groups. So you can start to see the context of questions of our world and claims made by groups in our world, whether it's political, social, right? You can see a group like 36 to 45-year-old drivers compared to 16 to 25-year-old drivers. Like an insurance company would want to know, is there a difference between their accident rate, right? So these questions pop up all along in our world. And so what we're looking for is a way of doing that, and we're going to do that specifically either with what's called a two-proportion z-interval test or two-proportion z-test. That would be with proportions. We use the z methods, right? The test statistics with it was a significance test, right? Or the z-critical if it's an interval. Again, we're using those to compare what we call two independent populations, two groups that are not somehow connected in any way. They're two separate groups. We'll talk more about that. And then the means, we use two sample t-intervals and two sample t-tests, right? Our IQs for people who attend college different than those who do not. Our two groups, college versus non-college groups, men versus women. Are men on average taller than women, right? And in order to do this, what happens is we look to compare values, to compare two values. And the way we do that is we look at the difference between two values. It's important to remember mathematically that the difference is the distance between two values. And the way you do that mathematically is with a subtraction. So is there, what's the difference between mu1 and mu2, or p1 and p2, right? Those population parameters, right? Is there a difference between those two groups? And mathematically or statistically, what we want to do is we want to look for how those two parameters vary, right? How much difference is there between those two population parameters? And so in this case here, what we would be calculating is the standard deviation of those differences. Okay, so, and you can see it looks kind of complicated, but you've seen this before. You've seen that that notation before. Similarly, if it was a mean, we're looking for the standard deviation between those means, the differences, right? And when we look at these distributions, of course, it's called the standard error, right, of the statistic. And you see very complicated formula, degrees of freedom. You can see complicated formula. Luckily for us, we're going to focus on doing these tests and intervals using technology. So we'll go ahead and do that in the next time.